So, we discussed about the polymer or ceramic insulator which are used for high voltage and extra high voltage transmission systems. We were mentioning about the glass insulator. So, glass insulators are also are being used for extra high voltage and ultra high voltage transmission. One of the most of the type tests are carried out in similar to the ceramic or porcelain insulators. So, one of the experiment which has been carried out in the laboratory is the artificial rain performance of the glass insulators. So, we would like to see a small video clip of the performance of the glass insulator. So, the voltage is applied in steps and the moisture or the rain through the fog nozzles as per standard is generated in the fog chamber. Then the voltage is increased. We find that the discharges from the conductor end towards the ground, the scintillations or a partial arcs will be observed initially. Later on, as the voltage increases, the stress across the string increases, the conductivity on the surface of the glass insulator increases. A further increase in voltage will have a breakdown or the flashover across the entire insulator string. So, one such example you can see here. This is a chamber specially made for pollution studies, where you can see the having glass insulators in 6 insulators are in service. This is a high voltage conductor where the voltage is taken from 150 kV to amps. So, the voltage is applied here, you can see the discharges on the surface, the scintillations or partial arcs initially, then the depending upon the surface conductivity, the scintillations increase, further increase in voltage will lead to a complete breakdown or the flashover. So, this is one of the experimentation for conducting the wet and pollution. This you see the entire flashover across the string. During the flashover you also observe the fumes of hot fumes which are like a smoke coming out of the during the flashover process. So, now we have discussed about the ceramic and the glass insulators. The reliability of the testing aspects have been discussed. As we know that presently a more advanced type of material that is the silicon rubber or a composite or a polymeric material is being employed for the transmission systems and distribution systems also. So, reliability of the composite insulators or polymer insulators, these being organic in nature, are very important. Not only carrying out the regular testing aspects, these being organic material have to be tested for more reliable for the long run in the field to give us a good service in the field. So, the composite insulators have increased over the period, particularly in the country. For a decade or so we are being using it for distribution voltage levels to the ultra high voltage levels, both for AC and DC applications. So, with increased use of synthetic or a composite type of insulators, the utilities are facing additional problems, particularly like tracking and surface erosion. So, as a result, a entire new dimension is being added to the area, particularly pertaining to the performance of these composite or polymeric insulator which are being used as outdoor insulator transmission system. Further, with increased demand for the power transmission in the country, many or more number of high voltage DC transmission lines are being executed and are being planned in our country. So, here again as the voltage level goes up above 400 kilovolts, as mentioned, the pollution or a contamination phenomena is a very important aspect to be considered for the design of line insulation. So, the pollution flashover problem is much more observed to be much more severe in case of DC than with alternating voltage. So, which is evident because of the practical lines which are operating in the country. So, there is a requirement, a significant activity pertaining to the performance have to be carried out further in the laboratories, research laboratories, and to see that how the problem could be tackled, particularly pertaining to the performance, the degradation of the surface of rubber insulator and so on. So, these are various types of insulators which are being used for a distribution class to a very high voltage levels, both for AC and DC transmission system. So, it consists basically, as mentioned earlier, end fittings with a polymer fiberglass rod and a polymer sheds or a silicon rubber sheds. So, important properties for evaluation, like checking the reliability is very important. So, not only the regular testing standards which have been prescribed, not only following the testing standards, as these insulators are of recent origin. So, the important properties for evaluation are being categorized, particularly the CGRE working group. The CGRE is an international council on large electric systems. So, this international group mainly focuses on the standardization of some of the properties pertaining to the insulators. So, this CGRE working group D114 has recommended or has been recommending the properties which are to be evaluated for a polymer or a composite or a silicon rubber insulators before actually the standards have been evolved. Some of the standards have been already evolved, but still some are in the stage of evolution. So, you can see here resistance, example resistance to tracking and erosion, the standard is IEC 60587, which is already evolved, and where the methods for conducting of the experiment is being given in the standard. For HVDC, resistance to tracking and erosion has to be evolved. For AC, it is already been established. In case of resistance to corona and ozone, so corona and ozone will degrade the surface of the polymer insulator. So, this particular standard it is still work is under progress, it is not yet standardized. So, the standard has to come up. So, CGRE working group is working towards the standardization of this procedure. Similarly, resistance to chemical and physical degradation by water, it is standardized, where IEC 62217 clearly explains about the water diffusion test for the polymer materials. Likewise, the mechanical strength, that is a tear strength, the volume resistivity, the breakdown of field strength, resistance to chemical attack, then these parameters or properties are also being standardized, like which are given here. Various International Electrotechnical Commission standards have been evolved for evaluation of these properties. So, similarly, resistance to flammability, resistance to weathering and UV, that is climatic aging or climatic conditions performance of these insulators, still the standards are not yet available. So, the CGRE and many researchers across the globe are working towards the area, suggesting many methods to be followed before the process is being standardized. The arc resistance for the during the surface discharge arcs is again specified for low and medium and high voltage arcing, which is specified in IEC 61621. Similarly, gas transition temperature, it is mentioned in 61006 IEC, and hydrophobicity, this is very important property of the polymer insulator, where the water repellent property on the surface of polymer insulator has to be verified. So, this is important property where hydrophobicity, stability, this is still under consideration. So, the standard is not yet evolved for hydrophobicity. So, many researchers are working. So, when you look into the 12 mentioned properties here by the Segre working group, out of these 12 there are 4 which are not yet standardized. That is, one is resistance to corona and ozone, resistance to weathering and UV, that is a climatic effect of ultraviolet, then weathering conditions, then resistance to flammability, then hydrophobicity. These are 4 important parameters which the standards have not been evolved, and these have to be considered at a laboratory level before the performance have to be tested in the long run of the polymer materials in service. So, we know that for efficient power transmission require the high voltage and transmission insulators are which form the integral part are very important components, either it is a ceramic, glass or a polymer. So, polymer insulator offers many advantages than the conventional or ceramic or a glass. So, being organic, they suffer degradation. This is a very important point to be noted. This is due to electrical and also environmental stresses. So, the main point of the performance of this polymer insulators for a long period of time is one of the quantification to be done, particularly for the surface degradation and the insulation properties over a period of time in service. So, Segre working group which I mentioned earlier, which is an international body or a council for large high voltage systems, working group D114 as mentioned has identified 12 physical parameters to evaluate polymer insulators. So, resistance to corona is one among the important which has gained the research interest. So, many people are focused towards this subject and are being working towards the remedial or trying to see how the improvmental aspect could be done. So, in the field we see 2 kinds of corona which is normally originating from the line hardware like the corona control rings or the yoke plate or any of the hardware material, and sometimes the metal part of the insulators. So, the inception of corona could be from one of these aspects which the discharges are continuously bombard the surface of polymer insulator, and over a period the surface degrades because of the corona discharges. The second is the water droplet corona, which in case the hydrophobicity of the polymer insulator, if it loses the water repellent property, the droplet settles on the surface and there will be a triple junction which is formed on the surface near the conductor junction, where continuously the corona due to water droplet may also degrade or the insulator over a period of time, and the surface loses its further hydrophobicity and could degrade the insulator in the long run. So, these 2 types of corona could be simulated in the laboratory and has to be evaluated for the performance of the insulators which would be put in service. So, the research or the testing for the reliability testing is important, particularly for evaluation of the composite or polymer insulators. So, it is utmost important to see the corona studies have to be carried out on both that is AC and DC composite insulator samples, as these composite or polymer insulators are being used for AC DC transmission distribution systems, AC and DC long distance transmission systems, and also for distribution in case of AC. So, evaluating for the corona effect is of utmost importance. There is further the tracking resistance and erosion, which is mentioned in the IEC 60587 and IEC 60112 on tracking index is also important. So, the performance of this material as per these standards will evaluate the material and helps us to know the actual resistance, tracking resistance, and how depth the erosion happens in case of the insulator in service. Then there are reliability tests prescribed by ISC 61621, particularly the low current arc discharges, the current of lower current continuous discharges on the sample, which should be created where the discharges damage the surface and whether the material loses its hydrophobicity. This has to be carried out, which gives an idea for the reliable working in the field. So, for this there is a method which has been used, inclined plane testing method, where the inclined arrangement is made at a particular angle, and the material or the sample is fixed on the inclined plane arrangement, and either it is AC voltage or the DC voltage is applied for a known period of time for with a contamination, suitable contamination, which is being mentioned in the standard. The contamination, the droplets of contamination is being continuously made to pass on the sample, and the voltage is applied between two electrodes. The performance during the flow of contamination, the sample degrades itself and there could be erosion. So, this helps to see the performance of the sample, polymer sample in the field. The other important aspect or the reliability verification for the polymer full scale insulators or full fledged insulator or a prorated type of insulator is the accelerated aging experimentation. Accelerated aging experimentation again consists of 2 to 3 experimentation which are normally carried out in the laboratory. Basically the experimentation is a salt fog, which is not mentioned here, a salt fog experimentation which could be carried out for 1000 hours period. The second being the tracking wheel arrangement facility, where this helps the sample to get itself dipped in the known quantity of solution. Then it will have a phase where it gets dried and again it comes in contact with the high voltage. So, this facility and how the experimentation is being done will be discussed. Then finally, the facility for conducting multiple stresses, very important, this material being organic in nature. So, in the field this insulator is likely to experience multiple stresses like the temperature, effect of temperature, effect of humidity, effect of ultraviolet radiations from the sun, and also the ultraviolet radiations which may come from the corona control rings, the corona induced UV rays, and due to fog, due to rain, due to pollution. So, several of these aspects have to be simulated to see whether the insulator withstands over a period of time. These are some of the important experimentation which are necessary to evaluate the composite insulators for a long period of time. So, we will discuss each and all the important evaluations to be carried out on the composite insulators. So, for this to carry out the facility, it is necessary to develop a methodology how to evaluate, that is very important, to check the performance of this composite insulators when subjected to combined environmental and also corona stresses. So, this is very important point to be noted. So, corona is not only happening in dry conditions, so corona also happens in foul weather conditions or during the moisture conditions, which could aggravate the situation and it could degrade the insulator in a faster process. So, to understand the corona performance on composite insulators which are used for high voltage AC and high voltage DC transmissions systems. So, to study the degradation, surface degradation phenomena on samples using a methodology which is normally developed in the research laboratories or as per the standards which have been specified. So, for the analysis after the experimentation, either going in for the surface erosion studies, corona, or going in for aging analysis, aging studies. So, later on the interpretation of the results is an important factor. So, the interpretation of the results pertaining to the surface morphological changes which happen on the insulator samples, various methods are being adopted after the experimentation. These are some of the following which are shown are some of the methods. Apart from that, there are several other methods which are being used for the interpretation of the performance of these samples. So, few of them are the Fourier transform infrared spectroscopy, where this gives an idea about the surface degradation on the polymer samples. The X-ray photoelectron spectroscopy, the XPS, again it gives an idea. Then scanning electron microscopy, it gives the surface changes which have happened on the surface after the experimentation. Then they use infrared spectroscopy. Apart from that, TGA thermogravity gravimetric analysis and other mechanical analysis to find the properties of these insulators. So, electrically the leakage currents which are being used during the which are being measured during the experimentation could be help in categorization of the corona discharges on the sample, the effect on the sample, and it gives an idea about the changes of the leakage current, the magnitude over a period of time during the aging process. So, these are some of the methods which are being employed for the interpretation of the surface changes on this polymer insulator samples.